Welcome to Smart Architectural Programming, your source for structured professional insights into the world of software engineering. Today's video accompanies the foundational text introduction to Java that we published, and that teaches you the intricacies of how you can learn Java and set up a good foundation for becoming a good software developer in Java. So based on that text, this is an accompanying video to that, and we're exploring a core concept that every Java developer must master, and this is part of our chapter 8 of that particular book, the object lifecycle. So let's break it down stage by stage and step by step. So first of all, we need to understand what is the object lifecycle in Java. We need to clarify that concept first before anything. At its core, the object lifecycle in Java refers to the journey an object takes from creation through use and finally to destruction. So this basically means when you run a code file, how it's created, used, and finally destroyed from the memory of the computer. This cycle is crucial for understanding how memory is managed and how to write clean, efficient code which is bug resistant. So that is basically what object lifecycle in Java is. It's the start to end of a program being run, put into memory, occupying memory resources, going through its logic, and then destroying the memory resources that particular program is using. There are 4 primary stages in the object lifecycle that we'll be covering, and these are the 4 essential stages that you need to understand to ultimately internalize the object lifecycle concept in Java. So first particular concept that we need to focus on is object creation, number 1. And basically, the journey begins here when you create an object using a new keyword. Let me bring in my pen here so we can actually go over here. So you created a new object from a class using this keyword here. And basically what you're doing here is you're triggering the constructor of this particular class to create a new class and allocate memory to that object, basically. Not a new class, but an object. This is also where the dependencies are initialized and default values are set, and they occupy these resources when they're set up like this, basically. So that's the first step, right? Then you go to object usage, right? So here what you basically do is that after the creation phase, you basically use the useful phase of the object starts. What happens there is you invoke methods within the object. Basically, you have classes, you have set up methods within those classes. You invoke those methods when you create the object and access properties in that object, and the object serves its purpose, basically whatever that purpose may be. And while you're doing that, that is when the second phase of usage happens. And this is often the longest phase in an object's life, because here you're running that logic and actually ultimately doing what the object was created and the class was created to do, basically. The third stage basically becomes where object becomes unreachable, right? That's the third phase. And you need to focus on this particular code here as we go along, because this is important for you to internalize. Eventually, basically, an object may no longer be needed, right? If there are no references pointing to it, for instance, it goes out of scope or is explicitly set to null. It becomes eligible for garbage collection. So ultimately, at a point when there's no references pointing to it, basically by that we mean variables that are pointing to the memory location of where the object is stored, right? When those pointers are basically eliminated, right? And there's no pointer left to point towards the object itself, and basically it goes out of scope at that point, right? Or you can explicitly set the object to the value of null. What happens there is you're telling the object, object recording variable that, hey, don't need to point anything to anything. You're a null object now. What happens at that point is that particular object, which is completely inaccessible, right, or unreachable, becomes eligible for what we call garbage collection. And that's the next stage, basically, where with the object destruction or garbage collection happens. You need to understand the JVM garbage collector sweeps unused objects automatically. You never need to explicitly destroy objects, because instead the garbage collector of Java identifies unreachable objects and reclaims their memory, keeping your application efficient and leak free. So as you mentioned here, when no variable is pointing to that object, or the variable that is pointing to it is set to null, and it becomes unreachable, the garbage collector of Java automatically highlights that and reclaims the memory that is used by the object and makes it opens it up for reuse, basically making your application efficient in the sense that it doesn't utilize memory that should not be utilized anymore, right? And such a program is usually called leak free in computer terminology. So that is basically the object lifecycle. But we don't stop there. This topic doesn't end there, right? Because of all of this, one thing that we understand here is that garbage collection is kind of like a black box, right, in Java. And we need to understand that a little bit more, right? In the life cycle, that's the most important part. So let's try to delve deeper into that. So garbage collection in Java basically is Java's memory management. And it's largely automatic because of the garbage collector system that's set up. So how does it work? Here it works, and we're going to go over it simply explaining the high level of how it works. Number one, automatic memory management, right? So we need to understand that JVM divides heap memory into regions, basically. It could be a heap young generation or old generation, so on and so forth. That division depends on GC. We're not going to go too deep into that, and it's something that you might want to explore if you are really interested in it and you want to explore higher level of Java programming. But for the introduction level, you need to focus on that. The JC works in cycles, scanning memory for unreachable objects and freeing it. Most JVMs use generational garbage collection, splitting memory into young, old, and sometimes permanent generations. So that is what I was referring to earlier, like young generation and old generation of memory setup, right? So most Java JVMs are setting up the memory of the generational garbage collection. So basically use the generational garbage collection, right? Which means splitting memory into young memory, old memory, and permanent generations of memory. So that is what automatic memory management is and how JVM manages automatic memory management in Java. The next thing in the Java garbage collection concept that we're trying to understand is JC triggers, or garbage collector triggers, right? So garbage collection is triggered when memory is low on your PC, or the resources that you have access to become low. CPU becomes idle when there's no activity in your CPU and RAM, and the system explicitly calls the system.gc command, though this is only a suggestion for the garbage collector. Garbage collection is usually non-deterministic in the sense that you don't need to control when it happens, only what gets collected. So you can only manage what gets collected, but you cannot manage at what time this garbage collection should be done. Ultimately, the final step to understanding garbage collection, is finalization or deprecation, basically. So previously, there's an aspect to this that you need to understand, is that developers could override the finalize method to run cleanup code before an object was collected, right? You could do that. You could force Java to do collection earlier. However, this particular method was deprecated because it introduced performance issues and unpredictability. Instead, use try with resources and explicit cleanup strategies, and that should somewhat help you understand and control the garbage collection. Again, we're not going to go too deep into these concepts because this is just an intro level course. So with that, let's move on to the next concept that we might want to have some sort of understanding about, that is benefits of encapsulation and lifecycle management in Java. You need to understand that object lifecycle isn't just about memory, it's also a very important pillar in Java regarding object-oriented design and management, right? If you want to code with the object-oriented programming paradigm, this is very, very important. So you need to understand that encapsulation ties in with lifecycle management, and here's how it does that. So encapsulation basically promotes control, right? So by encapsulating fields, making them private, and exposing only necessary getters and setters, you control how and when object state changes. This aligns beautifully with lifecycle awareness. So how does that fit in lifecycle arrangement? So clean lifecycle transitions happen, right? When as you design objects to be self-contained with clear construction, usage, and tear down responsibilities, you reduce side effects and improve testability. This means lifecycle management in practice. Basically, what happens is that in larger systems, you may use dependency injection, factory patterns, or singleton scopes to manage object lifetimes. Frameworks like Spring even provide lifecycle hooks such as post construct and pre-destroy to handle setup and clean up cleanly. So again, like, I'm not going to go too deep into the intricacies of this because this is an intro level course. You just need to be aware of the certain aspects to it. So best practices that you need to take away from basically this video is always initialize your objects properly using constructors. Use try with resources for managing objects like streams and sockets. Avoid relying on finalize. Use explicit cleanup. Encapsulate data to maintain object integrity throughout its life. Understand that when and why objects become unreachable. Ultimately, you need to understand that that is basically a brief intro into object lifecycle in Java, and this is a much more complex and much more detailed topic. But it is also a foundational topic with far-reaching implications for performance, design, and maintainability. But just having a basic understanding takes you a long way in this topic, and going too deep into it might not be that necessary. So for a deeper dive into this topic and others, be sure to read our Introduction to Java book, available now from Smart Architectural Programming. Don't forget to like, subscribe, and hit the bell icon to get notified about more deep dive Java tutorials. Have questions? Drop them in the comments. We reply to every single question that we get. Until next time, keep coding smart.